You know, oh look, I have a mouse. Yes, I was going to talk about how Tcl is used in SQLite. I'm the SQLite guy, if you don't know who I am. And maybe some of you, I guess most of you know pretty much what SQLite is, but I am going to review this for the sake of those who do not. SQLite is an SQL database engine. It's different from most that you're familiar with in that it is not client-server. It talks directly to the database on disk. I've kind of broken these database engines into three categories here. You've got your traditional client-server SQL databases on this side. You've got these key value things over on the left side, and people call those databases, you know, like Berkeley DB or Level DB or something. I prefer the term storage engine because they don't have a schema layer, they don't have transactions. These are storage engines. It's a very important piece of technology, but they're not databases. But they'll call themselves that. They're embedded, they're key value. SQLite is sort of a blend of these. It's embedded, it's built directly into your application, but it understands SQL, it's transactional. You know, SQL is really important. When I travel, what I find is a lot of people really don't get the importance of SQL. A lot of people, especially younger programmers, feel like that SQL is just the wire protocol that you use to transmit your key value operations from your application to your server. But there's really some very powerful ideas behind SQL. Data abstraction is the key thing. The quote from the Mythical Man Month is, "Representation is the essence of computer programming." The fact that you have schemas is just invaluable. And you know, the whole NoSQL thing got started years ago. Google was kind of founder of this. You know, they want to just do key value stores everywhere. But Google has moved away from it. I mean, they've gone full circle now. And they forget, you know what? People invented SQL for a purpose. And so now Google has Spanner, you know, which is what they use for all their stuff. Also, you've got a declarative language. You know, with SQL, you're not telling the computer what to do, you're telling it what answer you want. And then you're throwing this over the wall and letting the database figure out how to compute it for you. Very powerful thing. And then you have transactions. So a lot of people come in, beginning programmers, they can do an insert statement, they can do a delete statement, they can do an update, and they say, oh, I know SQL, I can put that on my resume now, okay? But really, if you're not doing queries like this, you're not doing it right. And this is the sort of thing that SQL excels at. And so, anyway, that's a little background here. SQLites got started about 17 years ago. I was doing a project written in a mixture of C and Tcl Tk. The user interface was done in Tcl Tk. The compute engine was done in C. We had to pull a bunch of information out of a database engine, which was Informix, and that worked great. But then sometimes the database engine would go down, and we didn't control that. It was vendor-supplied equipment, and so there's nothing we could do about it. But when that happened, I would have to paint that dialog box, and it was my application that was painting it. And so I got the support call, and that was not a good thing. So I thought, why do I need this server sitting between my application and the database? Why can't I read it directly off of the disk? Because I was sitting right there. I mean, it's on the same machine. And I looked around, and there was nothing around that would do that. And I thought, well, I'll just write my own. How hard can that be, really? And turns out a little bit harder than you think, but no, because you know, I never, being a database guy was never in my career plan, and I'd never taken a class in database technology. I didn't know how to do it. I made this up, and if I'd known in the beginning how hard it was, we might never have had SQLite. But we got it done, and it turned out it went viral. It went viral back before we had the term going viral. And it's very popular today. It's used in just about everything. It's in every Android device, of which there are 2 billion outside of China and some unknown number inside of China. There's about 1 billion Macs and iOS devices out there. About half a billion.
It's actually many more than it's in pre-Win 10 machines a lot.
Yeah, it's not in all pre-Win 10.
That's right. There were rules about installing, but it's used all over Microsoft. But
it's not in all of them. Whereas in Windows 10, if you delete system
Yeah.
when SQLite3.dll,
And all the
you
SKUs.
break your machine.
And all the SKUs.
Yeah. So, it's using the boot process for Windows 10. So, it's in Chrome and Firefox and Safari, Skype, iTunes, WhatsApp. It's just used absolutely. There are more copies of SQLite in operation than there are people. And it's used in millions of different applications. There are billions and billions of instances of this running around the world. And there's probably trillions of SQLite database files in use. Trillions. It's just really unbelievable. And so if you think about it, there are more copies of SQLite in circulation than there are copies of Linux. We know this because SQLite's on pretty much every Linux system, but there's also a bunch of non-Linux systems that use SQLite. And so with the same argument, there's more copies of SQLite than there are copies of Windows. There's more copies of SQLite than there are copies of Mac. There's more copies of SQLite in use than all other database engines combined. Or any other applications out there. I think SQLite is the second most widely used bit of software in the world. I think that ZLive, the compression library, might be used more often than SQLite. Some people, no, it's not. It's actually not built in SQLite. But, some people argue that SQLite is used more than ZLive. I don't know. Who can count these things? But it's a very widely used bit of software. So people ask, well, how did it get to be so popular? What did you do right? And the answer is, I don't know. Okay, but I got some ideas, and I'm going to share these with you. One thing that makes SQLite very popular that I found is that, as delivered, it's a single file of source code. I'm going to trip over these power cables. Let me just push them out of the way. It's a single file of source code. You take, SQLite3.c, you drop it into your application, you compile it, and you've got everything you need. There's nothing else. There's no library to put in. And people find this very compelling. Now, of course, we don't edit that one big file. We actually have, well, and I'll get into that in a minute. The next big thing is it's an open file format. It's well documented. People have implemented alternative database readers based on the spec, and of course they came back to us and gave us feedback. Says, well, you didn't specify this little detail, and we fixed that. So it's well documented enough to do a competing implementation. An entire database fits in a single file on disk, which is cross-platform. You can take that file and copy it from your 32-bit big Indian over to your 64-bit little Indian machine, and it works just fine. Backwards compatible through 2004. It's very space efficient and readable by third-party tools. The format is fully described on that web page, which is surprisingly readable. Here's an amazing thing. Reading and writing content in and out of SQLite is actually faster than reading and writing it directly from files on disk. And this is a graph that shows. This is a graph showing an experiment where we're reading 100,000 blobs of approximately 10K each. The average size was 10K. Some were smaller, some were larger. And these were random, so they were uncompressible. And this was to simulate thumbnails. And we did 100,000, and one of them would read them out of SQLite, the other one would read them out of individual blobs on disk. And as you can see, SQLite is our baseline, and it's the fastest, and we're slower on Android, Ubuntu, Mac, Windows 7, and Windows 10. And you think, how is that possible that you can be reading faster? Because the database is a file on disk. Well, it turns out that when you're reading from individual files, you have to open and close each individual file. And the overhead of open and close is greater than the overhead of going through the database engine. So as the size of the blob gets bigger, just a pure read system call is faster than going through SQLite. And so as the size of the blob gets bigger, you get an advantage of reading directly out of files. On the other hand, if it gets smaller, it's much more advantageous to read and write from SQLite. Now, this is an audacious claim that an SQL database is faster from direct I/O to disk. So I have a white paper here that you can go and investigate, and I have detailed instructions and downloadable source code, so you can try this yourself on your system. And if you get contrary results, you're free to call me out. Okay, you should try this.
I've seen the same thing, and a big part of that's because when they open files, they have to ACL everything, secure check.
Sure.
There's a whole bunch of layers that go in.
Yeah. So, another reason that it's real popular with SQL, we have implemented aviation-grade testing. We follow Tcl'2017, which is the spec that you use for safety-critical software on airliners. 100% modified condition decision coverage in an as-deployed configuration with independence, meaning we got multiple tests for each branch. And this gives us very robust code, but more importantly, it allows us to do massive refactorings and changes and maintain the code with only 3 developers. And whereas other database engines like MySQL, there's like 400 committers. How many committers are there in Postgres, Carl? Less, but there's still a lot. I talked to the Postgres people, and they have very reliable code too. And the way they obtain reliability is they never change the code. If there's something that works, the whole team will agonize over it for months before they will change anything about it. You know, whereas Dan and I will go through and refactor it and throw out and rewrite entire subsystems, and that'll be a point release. It's not a big deal. So another big reason why SQLite is so popular, I think, is that it is in the public domain. Anybody can use it for any reason whatsoever. It's free to everybody to use for any purpose, and that's a big deal for a lot of people. But you know, and these are all important reasons, but I think one of the key reasons why SQLite has been so successful, possibly the most important reason why SQLite has been so successful, is that SQLite is really a Tcl extension that has escaped into the wild. Okay, it started as part of a Tcl Tk project that I was working on. And you know, even today, most of the code in the source tree, as opposed to the code we deliver, most of the code in the source tree is in fact Tcl. Here's a breakdown of the different languages of the code that's in the source tree. And you can see Tcl is, well, I think it's 53% of the total code base. Now most of that's test scripts, some of it is code generators, but even if you look over in the C part over here, the orange, a lot of that is in fact interfaces between, you know, it's customized Tcl commands that we use for testing. So Tcl is a big part of the original source tree. Now, when we deliver to our end clients, all of that is stripped out and we've just got the pure C code at the end, but as part of the raw source tree, it's mostly Tcl. You know, there's a single file in the source tree called Tcl SQLite3.c. This is the adapter between the Tcl language and SQLite. You know, SQLite works with just about every program. It's built into Python. It's built into to PHP. It's, you know, available. There are available options to run it in pretty much everything else. But the only adapter that comes native with SQLite is the Tcl adapter. And that file, Tcl SQLite3.c, was in the very first check-in to SQLite way back in 2000. It's the only language interface that is native to SQLite. SQLite is also very close to Tcl in that it has an unusual type system. Basically, SQLite 1 and SQLite 2, everything was a string. Does that sound familiar to anybody? Yeah. And then with SQLite 3, we needed binaries, so internally, everything is kind of a dual representation, kind of like a Tcl object. This, for the rest of the world, for the non-Tcl world, this is a constant source of consternation. People think, you know, oh, I love SQLite, but the type system's busted, you know. People have this idea that SQL is supposed to be, well, the word people use is strongly typed. Okay? In other words, if you've got a column that says integer, you can only store an integer in it. I think it's a purgative term. I think a better term would be rigidly typed or judgmentally typed. SQLite is, pardon me? Bureaucratically typed. SQLite is flexibly typed. When you create a column in SQLite and you say it's an integer, that is a suggestion. And it will attempt to store the data as an integer if that's possible to do that without loss of information. But if you take a 20 kilobyte string and stuff it into a field marked small int, it will store it, all 20 kilobytes. It's happy to do that. So if people find that a little bit disconcerting, it really only causes problems when people write an application and they originally code to SQLite and it's working great for them, but they've made a mistake and they're actually putting a 100 character byte string in a varchar 10, and then they flip the switch on their framework and try and run it on Postgres, and Postgres says, no, you can't do that. You said it's a varchar 10 and this string's 50 characters long, I'm not taking it. So that's the only kind people really run into trouble, but I do get a lot of complaints about that. It's based on Tcl. Tcl is used extensively in our build process. So remember, I was saying that we don't actually edit that huge 200,000 line file of SQLite3. We've got 135 source files, and a lot of those are generated as well. But after they all get generated, we run it through a tickle script, make SQLite3.c, and that generates SQLite3.c. It's not a simple copy and concatenation. It actually makes some code edits. It has to extract all of the sharp includes and actually inline the header files and that sort of thing. And it takes care to inline them only once and that sort of thing. And it makes some other adjustments to the code to change internal routines to be statics and so forth. This makes a big difference because the entire database engine is running in a single translation unit. The compiler is able to do much more cross-procedure optimizations, and it actually makes it run about 10% faster. Tcl is used for that. Tcl is used for lots of code generators. There's for generating the header file. The command line shell that comes with Tcl is a file called shell.c, but really in the source tree it's shell.c.in, and we have a Tcl script that makes some modifications to it. We've got other Tcl scripts that actually generate code. The numeric value for our opcodes and our bytecode engine, the header file that has the sharp defines that specify those numeric values. That's done by scanning the source code and looking at comments and pulling those things out, and this sorts of things. So we have lots of code generator scripts all written in Tcl. We, as part of our package, we deliver some utility programs. There's the SQLite3 command line shell, which is our canonical command line shell. But a lot of users, they get a third-party graphical shell. But the key one is SQLite3. We also have this thing called SQLite3 Analyzer. And if this is a utility program, we include binaries on the website. And a lot of people download this, and you type SQLite3 Analyzer, you give the name of a database file, and it gives you lots of statistics about how big your tables are, how deep the B-trees nest, what's the average size of a row. It's very powerful for analyzing your database. What most people don't know is that SQLite3 Analyzer is in fact a Tcl script that we have wrapped. And it's thousands of lines of output, and I don't have another slide on this, but I do have another slide on this because there's a secret undocumented option to SQLite3 Analyzer. If you give it -- Tcl Shell, instead of doing the analysis, it actually pops you into a Tcl Shell. And it's not the original Tcl Shell code. I just have this little Tcl script that it runs instead of its normal processing. And so that's a cool thing. So if you're ever out in the wild somewhere and you don't have a copy of Tcl Shell, but you do have a copy of SQLite, an install of SQLite on hand, you can just do SQLite3 Analyzer -- Tcl Shell, and you've got Tcl Shell. Now it doesn't. This doesn't include some of the utilities that are in Tcl Live, like I guess you have to have Tcl Live to do clock now and stuff. So and P array, which I'm always missing, or not in there because it's not in the library, but all the built-in commands are here. We also have a lot of tools that we use in our development process. Of course, we use Fossil was developed as the configuration management system to support SQLite. When we're working on the code, and we're doing diffs between the different versions, we use the Fossil diff command with the --tk option. I don't know if you're aware of this, but when you do that, instead of giving you a diff on the on the screen, or calling a third-party differ, it actually runs a small little TK program that shows us the side-by-side diff in a separate window. That's very helpful to us. And what's really cool about this is that there's this button right here in the middle, Save As. So if you have one of these graphical diffs and it's a save, you can press Save As, and it uses introspection to make a copy of itself. The script makes a copy of itself into a standalone file that you can then move to another machine that doesn't have Fossil installed, that doesn't have your original source files. It's just a script, and you run that script in an ordinary wish, and it gives you this same script. And this is really cool for collaboration. And we built this into our chat client, which I'm going to show you next. Now, the three developers, Joe Matashkin is one of them, you familiar to you all. Dan Kennedy is one who's been to one of these conferences. We all live in different cities. And so in order to work effectively, we need virtual presence. So we've got our own private chat room, which is using our own private chat protocol. And it is, of course, a TK script. And this is a screenshot of it. And I don't know if you can read it here, but I've got example diff.txt, and there's a button here that you can press. So if we want to send a file to each other over chat, you press send file, and it prompts you for the name of the file. And if I previously pressed Save As on that diff screen and created a file called example diff.txt, and now I send it over chat, and our chat, because we wrote it ourselves in TK, knows about these special files, and so I can just press wish, and the diff pops up. So we're collaborating on things, and I've got some change I want to check in, and I'll just do a quick diff and save it and send it over to Dan or Joe and say, hey, look at this. Does this look right to you before I check it in? And they can pop it up and look at it before I do a check-in. And that's really cool. Now, see, a lot of other people, when they're collaborating, they'll use a commercial product like, what's the big thing? Hipp chat is the big thing now, or something? Slack or something like that. But it's a commercial tool, and that's all some really cool things, but you can't optimize it to do what you want to do. You can't customize it for your particular workflow. You got to do only what they do. But if you're working with these powerful tools like this, we can optimize it to be very fast and powerful for us. So another thing, every line of code in SQLite that I have personally written has been written in a text editor that I wrote in the 1990s in TK. Okay, this is my personal text editor. It's based on a text widget. And this is where I do all my text editing. It has Emacs command bindings, but I've customized it to do the sorts of things I need to do. So all of the code in SQLite, at least the part that I've done, is written in a TK text widget.
And that's available.
This is available online. Yeah, you can pull it down. Of course, why would anybody want to do this? This is my own personal IDE, so to speak. Yes.
It's really handy for when you can't count on Notepad being able to handle new lines. So
yeah, right. So this is very nice because it works cross-platform, sort of. I mean, the buttons look a little bit wonky when you bring it up on Mac, but it still works. And so I use it everywhere. I prefer this over Xcode. So this works really well. Another command, one thing that Mac has really done right is they have this command called open. Who uses the open command on your Mac? This is the most amazing. I love open. When I discovered open, that was amazing. I especially love open -F. Okay? And the problem is open does not exist on Linux, which is my primary development platform.
Not quite. It's called xdg-open.
Well, you know what? I have a command called open, which is in fact a Tickle script, which is on every one of my Linux boxes, and I need to go faster. So we use that. And so the Tickle documentation is also generated purely, well, it's a mixture of HTML with Tickle embedded. So when we're generating the documentation, which is rather extensive, we run a Tcl script that goes through and finds all these begin and end Tcl and runs that. And a lot of the documentation is generated by scanning the source code and extracting information from comments. Requirements, numbering, and tracking, all done with Tcl. You know, if you go to the website and you do a search, this entire web screen is generated from Tcl. So, you know, kind of the summary here is that, I don't know where that blue line came from, but the summary here is that, you know, SQLite, or Tcl, resulted in SQLite, which resulted in world domination. Okay, so, yeah, Tcl has led to world domination. You know, but there's some things that Tcl could do. You can learn from this. One is, it would be really cool if we had a make Tcl script that could take all of the Tcl source code and put it into a single file called Tcl.c that I could just drop into projects and have a complete Tcl interpreter. That would be so cool to have. How hard can this be? It doesn't, you're not compelled to use it. You can still do the original way of doing it, but having one big file that's just Tcl.c would be so cool. I encourage you to take that on as a project. You know what? I would really love to have crypto in the core. I know that I can package require stuff, but you know, but I don't like to, you know, mess with that. If I had crypto commands that were just built in, I can encrypt our chat room, and that would be a really cool thing to have. Yeah. No. So SQLite is an encryption. SQLite is a Tcl extension that escaped. Just want to talk about what are some things that we can do to bring SQLite back home. You know, it's left home. How can we bring it back? One thing that I want to propose is that, you know, maybe the SQLite3 command could be built into the core so that it's always there. You don't have to do package require SQLite3. Just going to put that out there. You know, SQLite is used as a data container. People think of it as a database. Think of it as a data container. People gather a bunch of information, they transmit it over to the application, and it's just a data container. Kind of like a zip archive, right? In fact, we have a little program called SQLAR, which is kind of a zip archiver, but instead of storing it in the zip format, it stores it in an SQLite database with that schema. You can download this and use it. And you think, well, that's going to be a lot bigger, right? Well, that's what my thought was. So I tried this. I wrote this program, and I tried it, and I did it. And you know, the first time I tried it, it was actually smaller than the zip archive. Okay, well, that was because I was using the zip archiver that was built into OpenOffice, which is kind of wonky. If you use a real zip archiver, it's slightly bigger. This is the SQLAR is about 0.5% larger than a real zip archiver. So it's very space efficient. You can try this out yourself. So think about SQLite versus zip. I mean, they both are containers for files. They both have trillions of instances in circulation. They're both very compact. They both have well-defined open formats. But if you go with SQLite, you have additional stuff. You've got a container for small objects, integers and stuff. Zip really only works for big files. Well, I mean, you can do small things, but it doesn't do it efficiently. You've got cross-platform objects. If you put an integer into a zip archive, you have to do byte swapping and stuff when you read it back out. You've got ACID transactions, a query language, secondary indices, triggers, and views. You've got all this extra stuff in your SQLite container that you don't have in your zip archive. So I'm wondering, why can't we type Tcl Shell and then give the name of a database? And it just, oh, this is a database. Let's look inside and pull our scripts out of there. And then you've also got a whole database there in which to store all of your secondary resources. Or why not allow the Tcl library to point to an SQLite database instead of a directory full of files? Or can we have a virtual file system that reads stuff out of a database?
I think Steve Huntley's done. We have at least one.
Yeah.
Okay, well,
Version of Tcl
and
a VFS for SQLite.
And then I'm out of time, but you know, a Tcl-based graphical database explorer would be a really cool thing to have. And finally, this is a pie in the sky thing. Tcl has this idea of a virtual table where it's not reading from the actual table in disk, but it's reading from an object. We could make a virtual table that mapped the widget hierarchy of Tk into a table. And so you could do really interesting things like you know, select star from Tk, and it would save your entire widget hierarchy. And then you could replay it and get it back, or you could do an update statement that could change all of your text from English into French in a single go. So, moral of the story is that Tcl resulted in SQLite, which resulted in world domination. So every time you get outside and you see somebody walking around and all the people you see are looking at their phones, know that Tickle had a very important role in enabling that phone. That is my talk. Thank you. I'm completely out of time. We can chat later.